Hi there, it's Chris here from Technical Networks. I'm making this video in order to show you how to configure port address translation, which is also known as NAT overload. So in my previous two videos, we talked about NAT. That is a technology that actually enables us to be able to translate our private IP address into a public IP address so that we are able to communicate on the internet because private IPv4 addresses are not allowed. They are blocked on the internet by the ISP. So and we said we've got three types of NAT, which we've got static NAT, dynamic NAT, and then port address translation, which is known as NAT overload. So we say static NAT provides one-to-one mapping of a local IP address to a global IP address. And then the dynamic NAT, we say it provides one-to-one dynamic translation of private IP address to a pool of public IP addresses. And with port address translation, is actually a version of NAT that allows for mapping of many private IPv4 addresses to mainly one or a few global, which is public IPv4 addresses. And with port address translation, it adds unique source port numbers to the inside global, and that's your public IPv4 address, to distinguish between translations. And part is the most common form of NAT that is used in most home routers. That is why several users are able to access the internet simultaneously at home. You can have 100 users at a time or more accessing the internet simultaneously. We are able to do this because of parts. So we're going to be jumping into the topology we are using for this configuration today. So I've actually done some configurations. This is a topology. So I've assigned IP addresses to all this server, and I've assigned IP addresses here as well to the interfaces of our local router and the ISP. And this is our LAN. So this is our inside local network, and that's our that's the outside local, that's the internet basically. And then the interface facing the ISP is our inside global, and the interface of the ISP facing us is the outside global of the ISP, because the ISP network is the outside network basically. So the steps in order to configure port address translation, so I've written them down here. The step one is to identify and configure the outside and the inside interface, which we're going to do. That is simply the interface facing our LAN is always our inside IP NAT, inside, and then the interface facing the ISP is going to be our IP NAT outside. So and then we specify which traffic can be translated using a standard ACL. So we're just going to be using a standard access list to identify the traffic and permit the traffic that will be translated to the public IP address. And then the step three will be to configure the port address translation. We're just going to use the command IP NAT source inside list, and then we name our access list number, and then the interface, which is our outside interface, is going to be part of the command, and then the keyword overload is what actually enables this to be doing port address translation. So we're just going to jump into action quickly. First things first, on our local router, I'm going to expand this. I'm going to say enable conft. Then we go to the interface gigabit 00, say IP NAT inside. That's our inside interface. We exit, and then we'll go to the interface facing the ISP. That's the interface facing the internet. So that's our inside global interface, and that will be our IP NAT outside. So we're gonna say interface at 010 IP NAT outside. And then the next thing we have to do is to configure an access list. We configure an access list, and then we're gonna permit our LAN, our local area network. We're gonna identify and permit it to be the addresses to be translated. So we're gonna say access list. Let's use 5, or yeah, access list 5 permit. Then the network is 192.168.10.0, and then the wildcard max is 0.0.0.255. So that's about that. And then the third step to configure path is to now say IP NAT inside source list. Then the number of our access list is 5. Access list 5. Then we say 5. And then we're going to mention this interface now. And the name of that interface is interface serial 010. So interface serial 010. Then the keyword will be overload. And then path is configured. So we're just gonna verify our configuration quickly. Let's say Control Z. If we say show IP NAT translations, there is nothing yet. So let's say show run. Then section NAT. Yeah. So we're going to generate some traffic by making some HTTP request with the IP address of that server. So go to the browser, enter the IP address 60.3.3.5. Yeah, so that's that. I'm just gonna copy that. So I'm gonna make that HTTP request as well. Yeah, that's that. And as you can see, we've used only one public IP address, which is the interface facing the ISP. So, and we can see all these PCs, they are able to access the internet simultaneously without any issues. Because the HTTP request, it uses TCP ports. So the HTTPS uses 443, TCP port 443, and TCP translations in the NAT table stays for 24 hours. Even though, that can be reduced, you can configure that, the duration of time, and reduce it. But as long as that session is active, no one else is able to use the internet with the static IP, with the static NAT or with the dynamic NAT. Once the addresses in the dynamic NAT has been used up, no one else is able to access the internet until the NAT translation table has been cleared. So we can see these are the requests that we made. So those are the HTTP requests, which is using TCP port. And then the port number is 80, and it uses TCP protocol. So we can see from this inside local address, this is this PC 192.168.10.7 is using port 1025, and then it's translating that into the same public IP address that we've got on this interface. If you can see, this interface is 91.10.10.1. So it's using a unique port to send it out. And this same unique port is the port it's going to use to receive it and translate it back to our inside local. So we can see 91.10.10.1. That's our inside local. And then for this PC, the 10.5, we can see is using same 1025, but then is translating it into our public IP address inside global with the same port 1025. So when it's coming back, it's going to come back with this port number and it translates it back to our private IP address to be able to reach this. And that's the outside local and outside global. The HTTP request we made is on port 80, and that's the IP address of the server, and which is 60.3.3.5, and then port 80. So, and then the same thing here, we've got this here as well. So for the dot 8 PC, that's our inside local, is using port 1025, but then it's using unique port 1026 to send it out. It's translating it to this public IP address inside global on this port, and then when it receives the packet again, the reply is using 1026 again and translating it back to this 192.168.10.8. And then for default PC, which is 10.6, is using 1000 and port 1027, and then it's using the same port. It's translating it to the same public IP address with the same port when it's sending it out, and then when it's coming back through this port number and this same public IP address, and then it's translating it back to our inside local. And then we can see the outside local IP address, which is the IP address of the server on the internet. And then the outside global as well is the same with the port number, TCP port 80 for HTTP request. So I think that's about that for the port address translation, NAT overload. So if you find this video helpful, give it thumbs up and click on the subscribe button at the bottom right of your screen to subscribe to our YouTube channel. Thanks for watching. See you in our next video. Take care.